Hi, this is Mrs. Dole, and today I'm homesick, so I hope this video helps you work through the assignments you have to do today. We're done with parent functions and transformations for now. They'll come back though. I know some of you aren't very excited about that. What we're working on this week is analyzing graphs and scatter plots. So today we're going to be analyzing graphs. So this says, assume that the following graph represents a distance versus time data collection. Use the picture to answer questions 8 through 14 that follow. So label your x and y axis. This is your y axis. This is your x axis. Distance is your y. Time is your x. You're going to answer questions 8, 9, and 10. Let me give you a hint on number 10. Number 10 says, during what time interval is the runner moving the fastest? Well, fastest is talking about speed. And so speed is like feet per second. Notice that's time. I'm sorry, distance over time. Or miles per hour. That's distance over time. So what you're doing is the change in your distance over the change in your time. So you're looking for the slope. And you want to know the fastest. So you want to know the highest or largest slope. So all you're looking for there is the steepest slope. So go ahead and have the teacher pause the video, and you need to answer questions 8, 9, and 10. Okay, number 8, your answer should be 4. Notice this is called a piecewise function because there are 4 pieces. Piece A, piece B, C, and D. During what time interval is the runner standing still? Well, notice A, you're not getting any further away, and D, you're not getting any further away. But I don't want you to write A and D. I want you to write from 0 to 4. And that might be seconds, that might be minutes, that might be hours. And this little upside down U means and. Also from 10 to 20 time units, whatever your time unit is. It's a good idea when it's a real life situation. You should write hours, seconds, minutes. Here you can just write time units right here. Time units. And then when is your slope the steepest? That's from 8 to 10, which is interval C, but we're going to say from 8 to 10. Use the numbers. Look mathematical. All right. At the bottom, make yourself a note that y equals a number is a horizontal line at that number. You can write that down now. For questions 11 through 14, match the trend line equation with the corresponding linear section on the graph that the equation best describes A, B, C, or D. Circle your answer below. Then state the appropriate restricted domain for each trend line. So each trend line means each time it has a trend. Like here it has a trend of staying flat, here is a trend of going uphill, here is a trend of going downhill, and here it has a trend of going just straight. It's just flat or constant. Okay, what I did was I changed these to y equals mx plus b lines. Of course, that's just a y equals 10, d is y. And then notice this one has a slope of 5/2, and this one has a slope of negative 15. Well, we already saw that the steepest slope is from 8 to 10, which is section C. 8 to 10 is section C. That's our steepest slope. So you can see your steepest slope right here is 15. So we know that this one is C. Then y equals a number is horizontal line. So we have a horizontal line at 10. That's section D. Oops, I circled the wrong one. Hopefully you're getting used to me being silly in these videos sometimes. And then y equals 30 is section A, up here where y is 30. So we're going to circle A for y equals 30. So that obviously only leaves section B, and that's your slope of 5/2. And if you notice, your rise right here is 10, and your run is 4. 10/4, that's your slope, is indeed 5/2. So this one is B. Did I mention I have a cold? I'm not doing so well. Okay, so B. All right, and then your domain is you're just going to tell what are your x values for section B. Well, my x values for section B are 4 to 8. And go ahead and tell what your x values are for D, A, and C, those sections. What are the x values for section D, for section A, section C? And again, the teacher can stop the video, and then you can check your answers. Okay, so you should have written those in. Section D goes from 10 to 20. Section A goes from 0 to 4. And section C goes from 8 to 10. Okay, turn your paper over. And what you need to do here is fill in the table from this graph, and then go down here and put these points, like this is a point, this is your x, comma, y, this is your time, this is your distance, and you're going to plot all these points on this graph. Over 2, up 50, over 4, up 80, etc. So on the subcomposite video, and you need to fill this in and put these on there. I would say that it should take you about 5 minutes, if that. Okay, so you should have filled in this table. Check your answers. You should have 70 for 0, 70, 2, 55, 4, 40, 6, 40, 8, 40. At 10, it's also 40. Is there 4 of them that's 40? 40. Let's see. Yeah. And then 12 is 20, and 14 is 0. Okay, then the next one, you had to put your points on the graph. You should have one at 0, 20, 250, 480. And notice that's practically a straight line right there. Keep that in mind. 610, 814, 1016, and 1218. And then it said you may connect the data points if it helps you find the slope of each piece. So we need to find the slope of each piece, because what we're going to do is write the equation that models the piecewise linear function on the time interval from 0 to 4, from 4 to 6, and 6 to 12. So we're going to write an equation for each one of those lines. So the first line goes from 0 to 4, so we just draw a line from 0 to 4. 0 right here to 4 right here. And then from 4 to 6 is going to be this little interval right here. And then 6 to 12 is going to be the interval, this last interval from here to here. And we can't draw an exact line, but it's approximate, like that. But what you're going to do is, for each one of these, you need to calculate your slope for 17, for 18, and for 19. And what you need to do, I almost wrote 19 instead of slope. And so what you need to do is use that formula for slope, that slope is y2 minus y1 over x2 minus x1. And so from the interval from 0 to 4, I would use like this point and this point to calculate your slope. From 4 to 6, you're going to use this point and this point to calculate your slope. And from 6 to 12, you have 4 points here. You can use any two. I would use the starting point, this one here, and the ending point, this one here. So let me do the first one with you. If I'm calculating the slope from 0 to 4, I'm going to take y2, 20, minus y1, 0. Oh, hello. y2, 20 minus y1, 80. Now you could have done 80 minus 20. It doesn't really matter if you do 20 minus 80 or 80 minus 20. It's almost easier to do 80 minus 20 so it doesn't end up negative, but it doesn't matter. But if I take 20 minus 80, I have to take 0 minus 4. And if you calculate this, you get negative 60 over negative 4, which is 15. So my slope for 17, for number 17, is 15. Well, now I still have to write my equation. To write your equation, write this. This is point slope form. You're going to use y minus y1 equals m times x minus x1. So y minus y1 is y minus, let's call, and you can choose a point. It doesn't matter which one. Let's call this y1, and let's call this x1. Even though a second ago, I think I called this y2 and this x2, but it doesn't matter. That was just for the slope. You can change your mind and call this y1 and x1 for this equation. So you get y minus 20 equals m, 15, and it ends up being a positive 15 because you have a negative divided by a negative, and then x minus x1, which is 0. And then what you do is you distribute. So we get y minus 20. I'll write it up here. Y minus 20. You might want to get a piece of notebook paper to do the other ones. Equals 15x minus 0. Well, 15x minus 0 is just 15x. And then what you have to do is you have to get the y by itself. Well, to get the y, because we want it to look like y equals mx plus b. So to get the y by itself, you just add 20 to both sides. And you get y equals 15x plus 20, because these cancel. And they're using d for distance instead of y, but this is the same thing. So d equals 15, let's say t for time, 15t instead of x plus 20. And that's what you're doing for all these. You find your slope, you plug your y1 and your x1 in right here and right here, and you can pick any point for your x1, y1. And then you distribute, and then you get the y by itself. So do that for 18 and 19. And then for number 20, what you're going to do is compare the slopes. So go ahead and, the sub can probably give you about 5 to 10 minutes to do that. So pause the video and do those. Okay, I'm not going to give you, I can give you those answers tomorrow in class. I want you to turn to the last page, Running Bob. It's actually a separate sheet. So get out Running Bob. And if you didn't finish these for some reason and you're a little bit behind, you can go ahead and do that, but you might have to finish Running Bob at home. So make sure you're being efficient with your class time. Okay, so you're just going to go ahead and use the rest of your class time to do Running Bob. I'm going to give you some hints on some of these. Like if you look at number 5, and again, all you're doing is analyzing this graph, answering questions about this graph. So if you look at number 5, whenever it says speed, it's talking about rate of change. And rate of change is the change in your distance over the change in your time, and the change in distance over change in time is just your slope. So rise over run. So that one is about speed. Number 9, it says, what's the average speed for the entire run? So for number 9, you just take your starting point and your ending point, and you find the slope. And then what is the interval where Bob's speed is the fastest? You're looking for the steepest slope. Net change means the difference, just the difference in the distance. If you want to make yourself a note, difference in the distance from 0 to 10 hours. Okay, how far did Bob travel in that time? Okay, so go ahead and answer those in maybe the last 3 minutes of class. I don't know how much time you have left. Or maybe tomorrow, if you don't have a lot of time, we'll give you the answers. So if the teacher paused the video and you need to go ahead and answer all these questions. Work efficiently, or you have homework. Okay, so you should have answered all these. Go ahead and check your answers. Number 1 is 3 to 5 and 7 to 15. That's when he's moving, if you notice, the distance is moving away from where he was toward home. I guess I just moved that whole sheet. Sorry about that. Okay, find the total distance Bob ran from 0 to 15 hours. He changed the distance of 3 miles right there, 3 miles right there, and 3 miles right there, a total of 9. What time interval is Bob getting closer to home? Just from 10, oh wait, no, closer to home. Right here's where he's getting closer to home. You know, I think I said that a second ago that this was the time he's not getting closer to home. Okay, so when is he not getting closer to home? From 3 to 5, he's not getting closer to home. From 7 to 15, he's not getting closer to home. Here's where he's getting closer to home, right here. He's moving closer to home here, and he's moving closer to home here. Again, that's just, I have a cold, I'm not thinking straight. So, and then number 4, 10 to 10.5. That's where he's moving away from home, because home is like down here at 0. Determine Bob's average running speed, so you just calculate the slope, and I'll show you where that is. We're going from 5 to 10, so we're going from here, this point, to this point, and you just take your rise over your run. So our rise was 3, and our run is 5. So 3 over 5 is 0.6. How many times is Bob 8 miles from his home? Answer, 2 times. How many times did Bob change his direction? Just 1 time. He was going toward home, and then 1 time he goes away from home right here at 10 hours. Alright, what happens 3 times as indicated by the graph? He stops, or he is at a constant distance away. Move that over so it's all on the page. Average speed for the entire run. The change from the beginning to end is 3. Up and down, rise over run. The run is 15 hours, which is 0.2 miles per hour. What is the interval where Bob's speed is the fastest? 10 to 10.5. That's where the steepest slope is. Determines Bob's net change in position from 0 to 10. From 0 to 10, you should have taken 12 minus 6, which is 6. What would be a reason for the graph going back up at 10 hours? Well, maybe he forgot something. Maybe he got lost. Maybe he's on a curvy road. He could have been any reason why he would have turned away from home to go back to his friend's house. What happens twice at a distance of 9 miles? He stayed the same distance away, or he stopped at 9 miles. And then, did Bob ever get home? No, the closest he ever got was 6 miles from home. Okay, that's it.